Hi guys, in the last video we had learnt about how to left rotate an array by 1. In this particular video we would be learning how to left rotate an array by d. So suppose you are provided an array which goes as or a list which goes as 1, 2, 3, 4 and 5. Okay. And you are provided a value of d which is equal to 2. So what that means that you have to take these two elements and you have to shift them to the left, that is they would go to the end. So you have to shift the entire array to the left by 2 digits. Okay, so the result that you would be getting at the end of this rotation would be 3, 4, 5, 1 and 2. So this would be my result. Okay. So this is how you would how your particular left rotate of an array would work, and you must always know that the d must be less than equal to n, and in case if d is greater than n, then you can perform d mod n, because if suppose the value of d is equal to 5, it would be a mod value. Yeah, if the value of d is equal to 5, the effective rotation would be equal to 1, because after rotating 4 times you would get the for example, if the length of the in this case if the length of the array is 5, if the rotation is given as equal to 6, then you know that after rotating 5 times you would be getting the same array that we had provided as an input. So for the 6th it would be equivalent to the first left rotation, right? So if you perform d mod n, you would be getting the same the effective value of the number of rotations even when d is greater than n. Okay, so this is how left rotate of an array by d takes place. So what we would do in order to perform this left rotation, the first method that we would be trying is the left rotate by using the left rotate function that we had used in the previous example. So in the previous example we had seen that we had shifted the left we had left rotated the array by 1. So if we call it d times, we would be getting the resultant array if it is rotated d times. So if it is left rotated d times, so we have to call that particular left rotate function by d. Okay, so we have our left rotate by 1 function. So now let's call this a naive method. So def left rotate d 1. Okay, this is the first method, so I'm providing a value of 1. So add n and d. Temp is equal to so this is my d1, and I would be calling my left rotate by 1 multiple times, that is equivalent to d. So for I in range d, I would be rotating my left array by 1 every time. So left rotate by 1, I would be providing my array, and I would be providing the length of the array as n. So it is I would be just passing the parameters, and I would be assigning it to a value, assigning it to the same value add, and at the end I would be returning add. So left rotate by d1 would be my function, and I have to provide left rotate by, there's no by here, so left rotate, and we have to provide 2. So if we are providing 2, the output that we must be getting is 3, 4, 5, 1, 2. Let's run our code and see what we are getting as our output. Let me just, yeah, So we are getting our output as 34512. So this is how we can perform left rotate of an array by d spaces. But you can see that this particular method has a complexity of, this particular code has a complexity of n, and this particular code has a complexity of d. So since we are calling the function of n d times, so the order of this, or the time complexity of this particular function or this particular algorithm would be order of dn, or order of nd. So this is not a particular good solution because it is coming in almost of n square, that is, it is a multiple. So we would try to ignore it. We would try to find another way of solving this. The second method that we would be doing is using the concept of slicing in Python. So in case of slicing, I need to place these two elements at the end, and I need to place these two elements at the starting. So what I would be doing, I would be starting from the dth index, that is, since d is equal to 2, so, and the indexes are 0, 1 and 2, I would be starting from the dth index. I would be going till the end, and I would be so this would be my R, and I would be concatenating the list from the first half, that is, it would be R of starting, there would be a colon here, to D. So if I concatenate these particular values, since I have provided D here, so it will take the values till D from 0. So 0, 1 would be included, that is, the values 1 and 2 would be included at the end. And if I concatenate this particular values, I would be getting a list that is left rotated by D. Let's see what we are getting as an output here. So def, so I would be calling this particular problem a better solution. So it would be left rotate d2, and we would be passing the values array, the size of the array, and d, that is the number of rotations that has to be done, and we would be returning R of, we would be first starting from D and we would be going till N, and then we would be concatenating it to R, and we would be starting from the first index and we would be going till D minus 1th index. So we would be providing D as the parameter here, and we would be providing D2 as the function call here. Let's run our code and see what we are getting as our output. So we are still getting 34512 as our output. Let's provide 3 here. The output that we must be getting is 45123. Let's run our code. So we are getting 45123. So as you can see that using slicing also we can perform left rotation. Now for the time complexity of this particular thing, so this you are taking for n minus d times the complexity of traversing from dth index till the end would be equal to n minus d. So as you can see that this particular thing would be giving me n minus d times, and this particular thing would be giving me d, right? And in order to assign all of these to a new array, we would be taking n. So the entire so we would be taking n minus d and n minus d plus d and plus n, and since we will be assigning it, so we are getting a value of 2n as a complexity. So this is the complexity for slicing a particular array and assigning it to a particular value. Okay, so this is how we would be performing left rotate of an array using slicing of lists in Python. Now for the third method that I consider to be the best method, because it also does it in 2n, but it does not require any auxiliary space, as in case of this particular slicing. It requires an auxiliary space where you save these particular arrays in a temporary memory. So in the third method there is no such concept of auxiliary space required, and we would be solving it using in order of n time complexity only. So let's remove this particular section. So what we would be doing is that first we would be reversing till the dth index. So we would be reversing the first part, that is we would be getting 2 1 3 4 5, then in the second iteration we would be getting 2 1, and then we would be reversing this particular section, that is 5 4 3, and in the last reversal we would be reversing the entire array. So in the first part we would be reversing this, in the second part we would be reversing this, and in the last part we would be reversing the entire array. So we would be getting 3 4 5 1 and 2. So as you can see that this is equal to the result that we were getting when we were right shifting our array by 2 or a list by 2. So this is how you can use the reverse operation in order to left shift your particular list or array. So how to code this particular solution? As you had learned before, we had learned how to reverse a particular list, right? So in order to reverse a particular list, let's create a function def reverse, and we need to pass in the parameter add as well as the indexes, that is low and high, and instead of low and high you can also pass in the length, but in this particular case we would be passing in low and high, as we would be passing these parameters while we are calling the function. So while low is less than high, we would be swapping the values. So add of so we would be saving it into a temp variable. We would be using a third variable in order to swap it. So temp is equal to add of low, and add of low is equal to add of high. So we are assigning the value of low index of the element of the low index of the high index into the low index, and then since we are swapping it, and then we are providing the high index with the value of temp. Okay, now we have to increase our low by 1 and we have to decrease our high by 1. So this is how we would be reversing our particular array. If you're not understanding it, we have solved this particular problem before, and you can find it in our playlist. Okay, so this is how you would be performing reverse. Now we would be performing 3 reverses, right, as we had seen before. The first reverse would be till the dth index, and the second reverse would be from d till the end of the list, and the third would be the entire array. Okay, so now let's write the code for reversing. Let's just write the code for the rotate, that is the best method. So def it would be left rotate d3, and we would be providing add n and d as the parameters as we had seen before. Now first we would be reversing our array. So let's just return our array here, and add is equal to reverse of add, and we would be first flipping the bits from till the dth index, that is from 0 to d minus 1, and then we would be flipping the bits for ARR from d to n minus 1. Then we would be flipping for the entire array, that is reverse of ARR 0 to n minus 1. And then we can return ARR. Let's just call this particular function d3 here, and let's just pass parameter 2 here so that we get a different result in this case again. And the result that we are expecting is 34512. Let's run our code, and as you can see that we are getting 34512 as our output of this particular code, and this is really fast in execution, that as it takes only order of 2n in order to get executed, because this particular statement takes order of d. It would be this takes an order of d, this takes an order of n minus d, and this takes an order of n. So the entire summation would be giving me an order of 2n, and as well as there is no other auxiliary space required, so there is no space complexity involved also in this particular code. So this is how you have to perform left rotate. I have taught you 3 methods in this video. I have told you about 3 methods in order to perform left rotate by d digits, and it's up to you. The slicing it is very easy to do, and you can do it in a much easier manner, but it also requires a space complexity. In order to avoid that, you can also use the third method, which I consider the best. But if you are doing a big problem and you need not and you cannot particularly code this big and there is a time shortage, then you can go for the slicing. But if you are coding for a smaller problem and you have a good amount of time left, then you can go for this particular solution. That is the best solution that we have done using the reverse. So thanks for watching this video, guys. I hope so this helped you. See you in the next one.